Hey there guys, this is the second page of your review covering problems 9, looks to be 216. Hopefully this one isn't as long as the first one, but I'll try to go a little bit faster. We'll see. So in a certain city, we have a travel car that has a value of $150. Every time the car is used, there is a $2.50 charge that is deducted from the card. So part A tells us we have to write a formula in the form of T of X for the amount of money remaining on the card after it's been used X times. So I'm going to have T of X equals MX plus B. And I have to fill in each of these values. Now, it tells me $2.50 is deducted from the card every time it is used. This is my rate of change. This is my M value because it changes each time it's used. So after one use is $2.50, 2 uses $5, 3 uses $7.50. So I know I'm going to have 250x, but it is deducted. So minus or negative 250x. And then I have my T of X here. For your B value, your B value is your initial value or your starting amount. In this case, this card starts with a positive $150. Another way you can write this formula is T of X equals 150 minus the 250 you deduct every time you use it. Either way, writing the formula is fine. This way makes a little bit more sense in the context of the problem because you understand you're taking away the 250 every time you use the card. But either way, it is fine. Part B says, okay, find T of 6 and explain its meaning. So it's saying, hey, plug in 6 for X. So if I plug in 6 for X, so T of 6 is 150 minus 250 times 6. You'll put that into your calculator, and after you put that into your calculator, you should get T of 6 equals 135. Now what this means is, remember, X represents how many times the card has been used. So after using the card 6 times, you have $135 left. So that's what it represents. Part C says find the number of times the card has been used when it has $150 or $105 remaining. So in this case, we're going backwards. They're telling us how much money we have remaining. They want us to figure out how many times have we used that card. So in this case, I plug in the 105 for Y, and I want to figure out X, the amount of times the card had to be used to get it down to this amount. And it should be 150. Whoops. There we go. So you'll either do n solve or use your calculator solve. So you'll subtract 150 from both sides, and then you'll divide by the negative 2.5, and you should get X equals 18. What this means is you have to have used the card 18 times if you have $105 remaining. And then part D says find your domain and find your range. So to find the domain of this function, we have to figure out the least amount of times we can use the card up to the most of time the card, or amount of times you can use the card. Now, we know that when we have graphs, we have two ways of writing domain. We have something where we have a list when we have discrete graphs, individual points, or an inequality when we have points connected by a line. So the first step before even writing the numbers for domain and range is determining, am I going to write domain as a list, or am I going to write domain as an inequality? So you consider your problem. You think, okay, are these going to be individual points or connected points? And mostly the shortcut is asking, can I do or take my X values in half, or do decimals for my X values? My X values represent the amount of times I use my card. So can I use my card 7.7 times or 7.2 times? No. You can only use it 1, 2, 3, 4, 5, so on and so forth times. So I'm going to write my domain as a list. So my domain is going to be the least amount of times I can use my card is 0. Maybe I don't use my card. Then 1, then 2, then 3. We can do ... to show, hey, here's my pattern, I'm increasing to 1, and then write my maximum value. But you have to find your maximum value. There's different ways of finding your maximum value. You can put the equation into your calculator and figure out when you run out of money, when it's 0. You can n solve it. There's different ways. But basically, the maximum amount of time you can use your card is up to when you run out of money. You cannot use your card. Ideally, you shouldn't use your card after you have $0 left on that account. So 0 equals 150 minus 2.5x. That'll give you 60. So you'll find out, hey, I can only use my card 60 times. After 60 times, I run out of money. So once again, you could solve this, subtract 150 from both sides, and then divide by negative 2.5, you should get 60. If you check the answer key, it goes you step by step on how to solve those. So we have these. The range of your function talks about money, so the actual amount on your card. So for the range, I need to find my pattern. Now I know the least amount of money I can have on that card is 0 after I used up all the money. And it's going by 2.5 increments. And the most amount of card or money I can have on that card is 150. Now in this case, do not increase by 1. It's not going to be 0, 1, 2, 3 because my range increases or decreases by the 2.5. The range increases by 1, so that's why it's 0, 1, 2, 3. So this one is 0, 2.5, 5.5, 7.5, and my max is 150 because that's the max my card will have. Number 10. Ezekiel walks from the park to his house. After 7 minutes, he is 200 meters from home, and after 10 minutes, he is 80 meters from home. Assume that Ezekiel is walking at a constant speed. Find a model for the distance d from when Ezekiel is home in terms of the time he has been walking t. So we're going to write a formula. D of t equals m t plus v, where t is my x value. So we have to find my slope. Now notice they give us a set of points. After 7 minutes, he is 200 meters. After 10 minutes, he is 80 meters. And they tell me that t is my x value, my independent variable. And that makes sense. Your distance depends on how long you're walking. The more you walk, the farther you get. So let's find my slope. M equals, this could be your x1, y1, x2, y2. So 80 minus 200 over 10 minus 7. If you do the math, you should get negative 40. So I can start filling in my formula. D of t is negative 40t. And then we have my b value, my y-intercept. Remember, to find your b value, you can plug in any point. You can do the 7200 or the 1080. I'll do the 1080 because these are easier numbers to work with, but once again, it doesn't really matter. So 80 is my y. You have 80 equals your negative 40 times your x value, which is the 10 that goes here, plus b. You'll solve that and you should get b equals 480. Because 10 times negative 40 is negative 400. Add 400 to both sides, will give you 480. I'm mostly skipping through these because this video is shorter, so hopefully you can do the math in between. So your formula is d of t equals negative 40t plus 480. So that is all just for part A. Part B says, okay, determine how far it is between the park and Ezekiel's home. So we had to find distance. So when we read the problem, he says he walks from the park to home. After 7 minutes, he is 200 miles from home, and after 10 minutes, he is 80 meters from home. So in this case, what we have to do is we have to figure out the total distance between the park and his home. So if you're thinking about the direction, he is walking from the park to his house. And after 7 minutes, he is 200 meters from home. So that means from the park, he got 200 meters. After 10 minutes, he got 80 meters. So you're figuring out, you're getting closer. So you want to figure out when your distance is 0. So I don't know where I want to draw this. He is going from park to home. And we can see from the formula the distance is decreasing as the time goes on because he's getting closer to home. So we want to figure out, when is the distance 0? When is he finally at home? So you'll keep solving this. You will subtract 480 from both sides. You'll get negative 480 equals negative 40t. You're going to divide by negative 40 on both sides. And you get negative 480 divided by 40, which, oh, let me get my calculator. That'll give you 12. So he is 12. Now you don't say he is 12 from home. We are doing meters. He is 12 meters from home. Or it takes him 10 minutes. Or it takes him 12 minutes. Oh, whoops, I answered part C. It takes him 12 minutes to get home. And part B, we already knew. We know how far he is. It's at 480. Because that 480 is telling me, hey, this is the total distance. The distance is decreasing each minute, but the total distance is 480. So the distance between his home and the park is 480 minutes. To make that distance 0, it will take 12 minutes. And then you can sketch the graph by using a graphing calculator and making the general sketches. When you draw sketches, make sure to include labels for x-axis, y-axis, label your numbers on your sketch. And then really, really important, label your x and y intercepts. They don't have to be perfect sketches, but at least do that much. Part 11, or number 11, a linear function f is such that f of t equals 0 and f of negative t equals negative 1. Find the formula for a function of f. This is similar to the previous problem, except it's not a word problem. So we want to find f of x equals mx plus b. We have set of points here. We have 2, 0, and negative 2, 1. So we have 2, 0, and negative 2, negative 1. So we can find my slope, which is negative 1 minus 0 over negative 2 minus 2. And in this case, we get negative 4 over negative 1. My slope is 1 over 4. To find b, you just plug in a value. I'm going to choose this one because it has a 0 involved. 0 makes things a little bit easier. 0 equals 1/4 times 2 plus b. 0 equals 2 over 4 plus b. You'll subtract 2 over 4 from both sides, which simplifies to 1/2. So b equals 1/2. So we have f of x equals 1/4 x minus 1/2. The reason I went straight to 1/2, you'll subtract 2 over 4 from both sides, so we'll give you negative 2 over 4. Negative 2 over 4 can simplify to negative 1/2. So then they ask you to find f of 5. Once again, this just means plug in 5 for x. So f of 5 is 1/4 times 5 minus 1/2. Use your calculator for this. You should get, that'll be 5 over 4 minus 1/2. And that'll give you 3/4 or 0.75. Either as a fraction or decimal, however you want to write your answer. But that's your answer. F of 5 equals 3/4 or F of 5 equals 0.5 or 0.75. Number 12, the exchange rate from pounds to sterlings to Australian dollars is a pound is 1.73 Australian dollars. Find the number of Australian dollars equivalent to 70 pounds. This one is one where you can set a proportion, so we know that £1 is the same thing as 1.73 Australian dollars. And we want to figure out, okay, well, if we have 70 pounds, how many Australian dollars is that? So we set a proportion and then we solve, cross multiply, or the butterfly method, which will give you, man, I really don't have any space. This will give you 1x is equal to 70 times 1.73, or 70 times 1.73, which is 121.1. 1x by itself is x itself. So, remember this is pounds. So find the number of Australian dollars equivalent to 70 pounds. That is 70 pounds is equivalent to 121 Australian dollars. Part B, sketch the conversion graph. So once again, put this equation into your calculator, or we have to make the equation. You can either make the equation or find a bunch of separate points, but part C asks us to create a model, which just means write an equation. So let's write the equation, and then to sketch your graph, just write the equation in your calculator and kind of convert that graph that your calculator gives you onto your paper. But you can do part B on your own, or check the answer key. Part C. So it tells me I want to write it in terms of A of P, where A is the amount of money and P is the amount of pounds. So it looks kind of complicated. This is the same thing as y equals mx plus b, except x is p and y is A of P. So we want to figure out our rate of change. So for our rate of change, we want to figure out, okay, how much the amount of money in Australian dollars corresponding to pounds. Well, they tell you here in the beginning, they tell you, hey, 1 pound is 1.73 Australian dollars. So they tell you in the beginning already your slope. So 1.73. And you have to be careful because this is not your rate of change. This is saying, hey, this is how many Australian dollars you have for 70 pounds. Rate of change is per 1. So for example, 1 pound is 1.73 Australian dollars. So A of P equals 1.73p. For your B value, we had a chapter that briefly talked about directly proportional, or the ones where we do not have y-intercepts. Notice for this one, you don't really have a starting value. You don't have a B value. It's just directly proportional. You just have conversions that you can convert from one to other. So that's why we can do proportions. So there is no B value. So your equation is just A of P is 1.73p. Usually if it's conversions, it's directly proportional. It will never have a y-intercept value because it just converts naturally. So you'll say, same thing from like pesos to dollars. You don't really add a value to it. You just directly convert it. And then find A of 100, explaining its meaning. So A of 100 just means plug in 100 for P. Hopefully you can do that without a calculator. And you'll see it'll give you 173. And remember that this represents a model, which is the amount of money in Australian dollars. So this means given, because P represents pounds, given 100 pounds, you have 173 Australian dollars. And then for part E, find A of -1, or rates of -1 of 50 and explain its meaning. So this one is inverse function. So this is an inverse function. For inverse functions, we briefly talked about it, but it's good to review it. Inverse functions mean when you reverse your x and y values, so when your inputs become outputs and your outputs become inputs. So, for example, assuming our original equation, y equals 1.73x, I now change it to x equals 1.73, y, resolve it to get y by itself, so y equals 1.73 divided by x, which makes sense anyways. You're just going in the reverse order, so instead of going from pounds to Australian dollars, now we're going to Australian dollars to pounds, which will decrease the amount of money I have. So you want to find a inverse 50. So I'm going to plug in 50 for x, and that should give you 1.73 divided by 50 should give you 28.90. And this is pounds. So 50 Australian dollars is 28.90 pounds. Which makes sense. Ideally, we can logically think through it. So we have questions 13, 14, and I believe 16 for the second page before I move on. So let's go to 13. Find the intersection point of the graphs of the functions f of x equals negative x plus 5 and g of x equals 0.5x plus 4. There's two ways to solve this problem. One of the ways is that you can graph them and find their point of intersections. The other one is you can use LinSolve. So either way works. I'm going to use LinSolve. But remember, you can always just graph them and then find the point of your intersection of that graph. So, menu algebra. Instead of numerical solve supplementary equations. You're going to have two variables. And then you are going to look at your y values. So let's see. It is negative x plus 5. So y equals negative x plus 5. And 0.5x plus 4. 0.5x plus 4. And there should be a y equals. Now notice you have to use these variables. If you're saying, hey, we're using variables x and y, my equation should have variables x and y. And then this is your point of intersection. 0.06 repeating, 4.43 repeating. We can round it to 3 sig figs. So, 0.667, comma, and I believe the other one was 4.3. 4.33. So those are just rounded to 3 significant figures. Once again, you could have graphed it, you would have found the exact same point of intersection. You could also solve it algebraically, where you set them equal to each other and solve for x. Whichever way you want to find it, just make sure you have an x and y value, because it is a point of intersection. Problem 14, determine which of these functions have an inverse function, give a reason. Inverse functions are when you can reverse x and y. All of these will have inverse functions except C, because C does not have an input value. Notice it's just f of x equals 3. There is no x value that I can switch with my y value. So I cannot switch inputs and outputs. So C is the only one that cannot have an inverse function.